Saturn just revealed something strange, and it might disappear before we fully understand it. These two images, taken by James Webb and Hubble Space Telescopes just weeks apart, show two completely different versions of the same planet. One looks calm and familiar, the other exposes something far more complex and far less understood. And hidden inside these observations is one of the most bizarre features in the solar system, a massive six-sided storm at Saturn's North Pole that could soon fade from view for years. So what exactly did these telescopes see, and why does Saturn suddenly look like two different worlds? Let's find out. The biggest surprise in this story is that the same planet suddenly seemed to have two different identities. That is what makes these observations so powerful. Hubble looked at Saturn in visible light on August 22, 2024, while the James Webb Space Telescope captured it in infrared on November 29, 2024. Those are not just two nice images taken at different times. They are two different ways of reading the planet itself. Hubble shows the version our eyes would understand best. Pale yellow cloud bands, bright white rings, and a softer, calmer face. Webb shows something more layered and unfamiliar. Stronger contrast in the atmosphere, brighter icy rings, and unusual glow at the poles. That difference exists because the telescopes are not doing the same job. Hubble mainly captures visible wavelengths, which are excellent for tracking the color and structure of upper clouds and haze. Webb, by contrast, works in infrared, which lets scientists pick out clouds, chemicals, and atmospheric features at different depths. NASA and STSCI describe the combined result as a richer, more layered view of Saturn's atmosphere because each telescope is sensitive to a different slice of the planet. So this is not one telescope confirming another. It is more like two specialists examining the same object with different tools, and then combining their notes into one much clearer diagnosis. And that is how they got these results. Hubble's image came through the long-running OPAL program, which monitors the outer planets year after year, so scientists can track changes over time. Webb's image came later using infrared observations that can expose features invisible in ordinary light. When those datasets were placed side by side, Saturn stopped looking like a static postcard and started behaving like a layered system with multiple personalities depending on wavelength. That is the real breakthrough here. The beauty of the pictures grabs attention, but the method is what makes them scientifically valuable. What makes this especially exciting is that the images were taken only 14 weeks apart. That means scientists were not comparing a modern photo with one from years earlier. They were comparing Saturn over a relatively short interval while the planet was moving toward its 2025 equinox. In other words, this was not just a visual experiment. It was a timed look at Saturn during a meaningful seasonal transition. That gives the observations extra weight because they capture both different wavelengths and a real moment in Saturn's changing year. So the first lesson from this new finding is simple but profound. Familiar planets can still surprise us when we stop asking only what they look like and start asking what light is revealing. And once that question opens, Saturn becomes much more than a ringed icon. It becomes a weather world with hidden structure, which takes us to the next part of the story. These images matter because they turn Saturn from a famous object into an active system. That is a huge difference. A lot of people think of Saturn mainly as rings first, planets second. But this release is really about the atmosphere, and more specifically, about the fact that Saturn's atmosphere is not a smooth blanket. It is layered, dynamic, and full of long-lived activity. ESA said the infrared and visible observations reveal layers and storms in the ringed planet's atmosphere, and that wording is important. This is not a decorative detail, it is the core of the discovery. In visible light, Hubble gives scientists a clean look at cloud patterns and color variations. In infrared, Webb can sense different depths and highlight how light interacts with clouds, hazes, and atmospheric chemistry. That is why Saturn's rings appear so dramatic in the Webb view. NASA says the icy rings glow brightly in infrared because of their highly reflective water ice. The atmosphere also changes character. Instead of a softer yellow world, Saturn becomes a planet with sharper banding and more obvious structure. It feels less like a painted globe and more like a machine in motion. Then there's the polar mystery. In the Webb image, the poles show a gray-green glow at around 4.3 microns. NASA's release says this may come from high-altitude aerosols scattering light or possibly auroral activity. That detail is one of the most intriguing parts of the whole story, because it reminds us that even a planet we have studied for generations can still offer ambiguous signals. Scientists do not just receive perfect answers from a telescope, they receive clues. And sometimes the best clue is the one that forces new questions. What exactly is glowing there? How high is it in the atmosphere? Is it driven by chemistry, by incoming charged particles, or by a combination of both? This is why the finding is so important beyond Saturn itself. Giant planets preserve information about how planetary atmospheres behave on enormous scales. Their storms can last for years. Their circulation patterns can expose how heat, chemistry, sunlight, and internal energy interact. By studying Saturn's atmosphere in multiple wavelengths, researchers are not just learning about one planet's weather, they are improving models of how gas giants form, evolve, and redistribute energy. Live Science correctly highlighted that studying Saturn's atmosphere helps scientists understand both giant storms and the broader evolution of the planet over billions of years. And that is where the audience should pause for a second, because once you realize that each wavelength is revealing a different floor of Saturn's atmospheric building, the planet becomes more than an image target. It becomes a multi-layer puzzle. The visible view is not wrong. The infrared view is not more true. They are both partial truths. The special part is what happens when you put them together. That combined perspective gives scientists a more complete story than either telescope could provide alone. But if Saturn's layers are the scientific core of this release, its timing gives the story urgency, and that urgency centers on one of the strangest weather features anywhere in the solar system. The emotional center of this story may be Saturn's north polar hexagon. This six-sided jet stream is one of the most bizarre and iconic atmospheric features known on any planet. It was first seen decades ago, and NASA's Cassini mission later showed that it is a persistent structure tied to Saturn's northern polar atmosphere. What makes the new Webb and Hubble observations so compelling is that the faint edges of that feature can still be seen, and these may be among the last high-resolution looks at it for years. That looming deadline matters because Saturn's seasons are extremely long. One Saturn year lasts about 29 Earth years, so each season stretches for roughly 7 Earth years. According to recent coverage based on NASA's release, the North Polar region is heading into a long winter darkness, which means the hexagon may become much harder to observe in visible light until the 2040s. That does not make the current images the final word on the feature, but it does make them feel like a time-sensitive snapshot of a changing planet. We are not just seeing Saturn clearly, we are seeing it at a particular moment before conditions shift. And this changes how we should think about the whole release. It is not only a story about better images, it is also a story about planetary timing. The observations, taken 14 weeks apart, caught Saturn moving toward its 2025 equinox, when lighting geometry changes and the balance between the hemispheres begins to shift. ESA notes that as Saturn transitions into southern spring, Webb and Hubble will gain progressively better views of the southern hemisphere in coming years. That means this release is both an ending and a beginning, a possible last sharp chapter for the north and the opening of a new chapter for the south. There's also a deeper lesson here about how astronomy actually works. Discoveries are not always about finding a brand new object no one has ever seen before. Sometimes the biggest advance comes from looking again, but with better timing, better instruments, and a better strategy for combining evidence. That is exactly what happened here. Saturn has been watched for centuries, yet a visible light telescope plus an infrared telescope, working together across a key seasonal window, still managed to make the planet feel new again. That should tell us something important. There are still major discoveries hiding inside familiar worlds. So what do we learn from all this? We learn that planets are not fixed portraits. They are evolving systems. We learn that light is not just for seeing, it is for decoding. And we learn that Saturn's real magic is not only in its rings, but in the fact that every new way of observing it reveals another layer of complexity. That is what makes this finding so special. It does not shrink Saturn into a solved object. It expands Saturn back into a mystery. Saturn has been one of the easiest planets to recognize and one of the hardest to fully understand. These new Webb and Hubble observations prove why. They show that the same world can look calm in one wavelength and far more complex in another. They show how scientists got these results by combining visible light monitoring with infrared imaging. They show why the finding matters, because it exposes atmospheric layers, unusual polar signals, and a time-sensitive look at the famous hexagon during a seasonal turning point. Most of all, they remind us that even the most familiar planets can still surprise us when we change the way we look at them. How many more secrets are still hiding inside the planets we think we already know? Comment below with your theory. I'm genuinely curious. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. Your support truly makes a difference and helps this channel grow. Thank you for watching, and see you next time.